Okay, so what we're going to look at now are the energy equations. If you know frequency, you can figure out what the energy of that particular wavelength, or that particular frequency is, by using Planck's constant. This is another variable, or another constant that you should know. It's 6.63 times 10 to the negative 34th joules seconds. So we're going to be using this to go back and forth between energy and frequency, frequency and energy. So what's the energy associated with light, whose frequency is? So now we write out our equation, because we've got energy, so we're going to use the energy equation. Planck's constant times frequency. We don't know energy, so we're just going to plug in an E. We do know Planck's constant. We always know Planck's constant, 6.63 times 10 to the negative 34th joules seconds. And then we're going to use frequency that's given to us in the problem, 4.3 times 10 to the 14th, and then the seconds negative 1 I like to write like this, per second, because it means the same thing. So I can see right away that this is a very basic problem. I know it looks a little overwhelming because you've got some weird exponents there and you've got some weird units, but it's basically like saying E equals 2 times 5. 2 times 5 is 10. It's not hard. And they just throw in the units. So the math should be simple. And the units, if you see seconds up here and seconds on the bottom, you can see that seconds cancel out. You're left with joules, which is perfect because joules is a unit that we use for energy. So when you do the basic math here, you end up with 2.9 times 10 to the negative 19th joules. And that's the range that most of these energies are going to be in, times 10 to the negative 19th. It's a very small amount of energy. Remember, we're just talking about electrons jumping around here, not a ton of energy. So that's how you do that. And let's look at the opposite type of problem. It says, what's the frequency of light that has an energy? So now we know the energy. We just have to figure out the frequency. So energy equals Planck's constant times frequency. The energy in this case is 7.8 times 10 to the negative 19th joules. Planck's constant is always going to be 6.63 times 10 to the negative 34th joules seconds. And then frequency is going to be a variable, still frequency. So this is like saying 10 equals 2 times x. Let's get the x alone. Divide this side by 2. Divide this side by 2, so you put 10 in your calculator first. You want to get the frequency alone, so you're going to divide by this on both sides. So they cancel, and then you do this. 6.63 times 10 to the negative 34th joules seconds. Joules cancels, and I'm left with seconds on the bottom. My numbers will cancel, and I'll get a number on top, and then I have a fraction line, and I have seconds on the bottom. That means per second. So when I look at my final answer here, I've got 1.2 times 10 to the 15th with seconds on the bottom. So I could write it like that. I could write per second. I could write seconds negative 1. Or I could write hertz. They all mean the same thing. That many waves go by in 1 second with an energy of that.